Okay, here we go. This is the Newton's problem. Suppose that a cup of soup cooled from 90 degrees to 60 degrees centigrade in 10 minutes in a room whose temperature was 20 degrees Celsius. Use Newton's law of cooling to answer the following questions. How much longer would it take the soup to cool to 35 degrees? How much longer? Okay, so this is our basic setup. This is what we have. This is Newton's formula that we derived using differential equations. So we've got that to our, advantage to be able to use that. We've got T equals 0. T equals 60. T sub 0 is 90. T sub S is the surrounding temperature is 20 degrees, and the time is 10 minutes that this takes us to happen. So I started with 90 degrees. I cool down to 60 degrees in this room that's 20 degrees. I guess I could put degrees on all these anyway. I won't do this in the problem, but we can see that. So the 20-degree room causes the temperature to drop from 90 degrees to 60 degrees. So we have this relationship based upon the differential equation we derived earlier. Okay, so we just substitute our data in. So my temperature is 60 degrees. My surrounding temperature, it was 20 degrees, that's my room. And that equals, again, the initial temperature. So I started out at 90 degrees. Okay. That was the cup of soup when I started, minus 20. And that equals E to the negative K times T, and T is 10. So the first thing we're going to do is we're going to find the K for this particular situation. And then we can use it for the same cup of soup as we vary the problem of the parameters of the problem. Okay, so this isn't too bad. With 60 minus 20, that's 40. And 90 minus 20 is 70. And that equals E to the negative 10K. And we can divide both sides by 70, so we get 40 over 70, which is just the same thing as what? 4 over 7. And that equals E to the negative 10K. And then take the natural log of both sides, so the natural log of 4 over 7 equals the natural log of E to the negative 10K. And then I can move this exponent in front, so the natural log of 4 over 7 equals negative 10K, the natural log of E, and that's just 1, so in order to find out what K is, I divide both sides by negative 10. Or I can multiply. It's a little bit more economical to multiply by negative 1/10, so I got negative 1 over 10 times the natural log of 4 over 7, and that's going to be equal to K. So that's what my constant is, or my K, constant of proportionality for this problem. So A, we want to find out how much longer it takes to cool down to 35 degrees. Okay, we got it down to, I guess, 60, so we're going to go down more to 35. So we put this data in, and we're going to start right up here, so we'll make this 35. Well, actually, I should write the equation. So we have T minus T sub S equals T sub 0 minus T sub S times E to the negative, and what's my K? My K is negative 1 over 10, natural log of 4 over 7 times T. So there's my whole shebang. Okay? And then we'll put our new data in. It's only one new number, and that's going to go to 35. So we want to see how long it takes to cool down to 35. So 35 minus the surrounding temperature is still 20. The initial temperature is still 90. Minus that 20 again. E. I can simplify this. A negative times a negative is a positive, so it's just going to be 1/10 the natural log of 4 over 7 T. And 35 minus 20 is going to be 15. And this again is still 70, 90 minus 20. And then again e to the 1/10 natural log of 4 over 7 t. Then you can divide both sides by 15. I'm sorry, divide both sides by 70, pardon me. Divide both sides by 70. So we have 15 over 70, and I can reduce that. That reduces it to be by 5 to be 3 over 14. Okay, just a little bit. It's going to be 3 over 14. That's going to equal E. And rather than write this out all the time, I'll just call this K for a moment because I'm getting tired of copying it down over and over. I'll put it back in later because I'm going to take the natural log of both sides. So I'll have the natural log of 3 over 14 equals the natural log of E to the KT. Then I'll bring that in front so I get the natural log of 3 over 14 equals KT times the natural log of E, and that's just going to be 1. Okay? So I could rewrite this as the natural log of 3 over 14. And now I can write my K in, and my K is going to be negative. I'm sorry, it's positive now because I worked this up here, so I call this the actual K. So it's going to be positive 1 over 10 times the natural log of 4 over 7 times t. So that was what I kind of called K for a while to save myself a little bit of time in writing. And then in order to solve for t, I just multiply both sides by 10, and then I divide by the log of 4 over 7. So I've got 10 times the natural log of 3 over 14, all divided by the natural log of 4 over 7, and that equals t. If you work that on your calculator, you get about 27.53 minutes. And that was after 10 minutes. So if we subtract 10 from that, I'm going to read the problem carefully. They want to know how many minutes more. And then it actually gives us 17.53 minutes more. Okay, to get down to 35 degrees. Okay, now we got to go on because now we got a B part to this beast. And the B part says, okay, instead of being left to stand in the room, the cup of 90 degrees centigrade soup is put into a freezer whose temperature is negative 15 degrees centigrade. How long will it take the soup to cool from 90 to 35 degrees centigrade? So it's not more. We're going to start from almost from scratch. So this looks something like this. So we use our same equation. And then we just substitute our data in. So we've got 35 degrees is where we want to get down to. And now instead of it being in the room, it's going to be in the freezer, and that's minus 15 degrees. So that's 35 minus negative 15 degrees, and that's going to be equal to my T sub 0, which again was 90 degrees. That hasn't changed. But I got a new surrounding temperature, negative 15, so that's minus negative 15. And this is the same thing over here, E to the 1 over 10, the natural log of 4 over 7 T. And then this is going to be 35 plus 15, which is 50. That's going to be 50. And then 90 plus 15, negative is positive, is 105. That's going to be E. And then I'm going to have KT, and I'll call this K, this whole shebang K, just to save me some writing again. I take the natural log of both sides, so the natural log of 50 equals, oops, error. First of all, I have to divide by 105, so I've got 50 divided by 105. And that equals about, I can reduce that to be 10 over 21. And then and that equals e to the kt. Now take the natural log of both sides. So the natural log of 10 over 21 equals e, or the natural log of e to the kt. And I can bring this exponent in front. So I got the natural log of 10 over 21 equals kt. Now I'll put back my k. My k is going to be 1 over 10, the natural log of 4 over 7t, all right, times the natural log of e, and that's just 1, so that drops out. Then I divide both sides by the natural log of 4 over 7 multiplied by 10, so I end up with 10 times the natural log of 10 over 21, all divided by this natural log of 4 over 7. And now you're ready to put that in your calculator. And you'll get your t, and that's going to be about equal to 13.26 minutes when you put that in the calculator. Okay, so that's a pretty hefty problem. Okay, so I hope that's all right. And if you have any questions, I'll go over that tomorrow. But that second part's pretty tough.